Uh, Good afternoon, good morning, everybody. This webinar we are organizing is on advanced micro irrigation technology, and which will be delivered by Professor Yao Kang from China. And the background is that, as we all know, that agriculture has a larger share of water, and with a growing population, there is a requirement of more food production also. But because land and water resources are both limited, so we have to produce more food with less water and less land. And for that purpose, we have to go for efficient use of water resources, available water to increase the productivity. Although there are a number of techniques and technologies which can be used, but micro-irrigation technology for using drip and sprinkler has emerged as one of the key interventions for water saving and for improving crop productivity. Micro-irrigation technologies have shown improvements in yield, reduction in labor requirement, improvement in output quality. Evidence has shown that 40 to 80% of water can be saved and water use efficiency can be enhanced almost up to 95% in a properly designed micro-irrigation system. And the micro-irrigation system, the efficiency is very high as compared to conventional system. So this micro-irrigation use is now getting more and more in the different countries. And in an effort to raise awareness, conserve and use water resources in an integrated manner, ICID is promoting use of micro-irrigation and as a tool for efficient water use. And in that direction, every ICID is organizing international micro-irrigation conference, which provide a platform for both for local, regional, and national experts to come together and share their views. And with this background, I'll introduce Professor Yao Kang, who will be delivering this webinar. Professor Yao Kang is a PhD from United Graduate School of Agricultural Sciences, Aim University, Japan, and he did his PhD in 1997 and master's in 94 and graduation in 1986 from the Department of Soil Water Conservation, Beijing Forestry University. And at present, he is professor, Institute of Geophysical Sciences and Natural Resource Research, Chinese Academy of Science, Beijing, China. Professor Kang joined Institute of Desert Research in July 86, and then he worked in Institute of Geography, Chinese Academy of Sciences, and he is presently continuing to work there. He is a distinguished chair, professor of Chinese Academy of Science, professor at the University of Chinese Academy of Science, vice chairman, Micro-irrigation branch, China Association of Irrigation Area, and pre-director, Key Laboratory of Water Cycle and related land surface process. Professor Kang has a long history of research in the field of water cycle in soil, plant, atmosphere continuum, micro-irrigation, sprinkle irrigation, saline water irrigation, saline and alkali soil utilization for agriculture. He has received a number of awards, and he has received talent planning, the National Science Fund for Distinguished Young Scholars in 2001. Professor Kang has made internationally known achievements in both theoretical and technological aspects of micro-irrigation and sprinkler irrigation, drip irrigation with saline water and saline soil utilization for agriculture. He has published more than 270 papers, obtained about 30 national patents, 9 software copyrights, and he was one of the main members of setting national standards and professional standards. So with this, I'll request Professor Kang to start it. But before that, I'll request all the. I'll also introduce Dr. Wawa, who is one of the panelists for this webinar. Dr. Wawa at present is chair of African Regional Working Group, and he is also managing African Young Professional Forum. And this webinar is mainly for on that account, and he is as one of the panelists. He'll be helping Professor Kang and us in clarifying some of the queries which are raised by participants. And all the participants, they can send their questions either through chat or raise their hand when we can give them speaking rights, and at that time they can raise their queries. Otherwise, they can send their questions by chat. So now I'll request Professor Kang to start his presentation. Professor Kang, thank you.
Okay, thank you. Good afternoon and good morning. Now in Beijing it's afternoon, but in some of your countries, maybe now it's morning. My name is Yaohu Kang, and I'm from the Institute of Geographic Sciences and Natural Resources Research, Chinese Academy of Sciences. It is my honor to have a chance to give a lecture and to discuss about advanced micro-irrigation technology. So my research field is first is water cycle in soil plant atmosphere continuum. Second, micro-irrigation and sprinkler irrigation. Third, drip irrigation with saline water. Fourth is agriculture and vegetation construction in the field with saline arid soil. And also, we study for methods for hydraulic analysis and micro-irrigation systems, development of micro-irrigation systems. Our research results are mainly we obtained from experiment to study. And in the past 20 years, we have established about 20 experiment and demonstration stations in China. Currently, there are 6 stations under operating. Today, the contents my lecture including first, introduction. Second, effects of irrigation frequency on crop growth and water use. Third, effects of controlling soil moisture potential on crop growth. And fourth, irrigation scheduling for efficient use of water. And irrigation scheduling for both purpose of irrigation and fertilization. And lastly, finally, I introduce several micro-irrigation systems for different type of users. As we know, irrigation is very important for agriculture and food security. For example, over 75% of the country's total grains production, over 90% of the total cotton and the total vegetable productions are from about 50% of the total irrigated land areas in China. Micro-irrigation including drip irrigation, micro-sprinkler irrigation, and bubble irrigation. Micro-irrigation is the slow application of water on, above, or beneath the soil. The features of micro-irrigation are first, water is applied at a low rate. Second, water is applied over a long period of time. Third, water is applied at frequent intervals. And fourth, water is applied near or into the plant root zones. And fifth, water is applied by low pressure delivery system. This figure shows the soil moisture status and different irrigation methods. This yellow line is for the surface irrigation. This green line is for the sprinkler irrigation. And the white line is for the macro. From these figures, it can be seen that the water can be maintained in a very good conditions according to the rule of crop water requirements under micro-irrigation. So the advantages of micro-irrigation including, First, increase the beneficial use of available water. Second, include fertilizer and other chemical application. Third, enhance plant growth and yield. Fourth is limited weight growth and decrease the energy requirements, improve the culture practices, and reduce the salinity hazard to plants. The major issues of micro-irrigation for most developing countries, such as in China, are including: first, when to irrigation; second, how much water to apply; third, how to make this technology simple and easy for the farmers to accept. And finally, the water irrigation systems are more convenient operation, but more precision in applications of water and further for our farmers. In arid and semi-arid regions, salts in irrigation waters enters the soil with irrigation water. Leaching water must be considered during irrigation to prevent salt accumulation in the soil. Third leaching method suggested in the handbook of the United States as follows. And in these equations, it's very important to determine the ratios of additional irrigation water for salt leaching. But in these equations, we should first determine how much the evapotranspiration. But how to get correct evapotranspiration? As we know, to get correct evapotranspiration is quite difficult. So whether there is a more easy method for irrigation scheduling for both purposes of the irrigation and the salt leaching. So in 2001 and 2002, we selected potato and radish as experiment materials to study the water cycle process and the water consumption in drip irrigated field in order to develop a simple but accurate irrigation scheduling method for Chinese farmers. And why we choose the potato and radish? Because the potato plants are very sensitive to moisture stress because their root distribution are shallow. And about 85% of the roots is concentrated in the upper 30 centimeter of the soil. Water stress will cause significant yield cuts, but excess water may cause too many stems and leaves and affect the tuber yields and quality. Radish is one of the most important vegetable half of the year. It is one of the relatively drought tolerant crops. You see, we chose two kinds of different crops. So the instruments and observation system are as shown in these pictures. This is a control unit for drip irrigation experiment plant. And we developed the high-gain electronic weighing lattimeter with high accuracy to obtain the evapotranspiration. We also set the tensimeter for observation of the soil multi-potential distribution. And we also set the tensimeter for soil multi-potential monitoring. Sixth treatment for drip irrigation frequency of potato in the first half of the year, and the radish in the second half of the year were conducted in 2001. So the total amount of irrigation water for the different treatments was equal. and the treatment of irrigation frequency including first once every day, once every 2 days, once every 3 days, once every 4 days, and once every 6 days, and once every 8 days. So the irrigation amount per term for the once every day frequency was equal to the evapotranspiration of the previous day, as measured using the electronic weighing lattimeter. The accuracy of the electronic lattimeter we developed, that is the 0.05 millimeter. That means we can get the correct evapotranspiration. So irrigation amounts for the once every 2 days, 3 days, 4 days, 6 days, and 8 days was the cumulative values of the once every days. One side of the tensiometer with 30 probes was installed in each treatment for observing the soil moisture potential distributions under the drip ammeter. Because soil water potential is not affected by soil texture due to that it describes the continuous of energy state of the water in the soil. So plant height, leaf area, stem diameter, root distribution, yield, and soil nutrient distributions were measured during the potato growth. So, and we found that the yield of the potato decreases as the irrigation frequency decreases. And once every day, this frequency for potato, the yield is the highest. But once for 8 days is the lowest. But for radish, the yield is increases as the irrigation frequency decreases. And when it's reached once every 5 days apart, then it's become the yield is the highest, and then turn to the decreasing. And the evapotranspiration of potato is decreases as the irrigation frequency decreases. Radish has the same tendency. So the water use efficiency is for the potato is decreases with the irrigation frequency is decreases. Once every days for potato, the water use efficient is the highest. But for radish, it's different. The water use efficiency is increases as the irrigation frequency is decreases. And once 6 days, and the water use efficiency is the highest. Very important found that the soil moisture potential condition in main root distribution layer can be maintained when control of the soil moisture potential at 20 centimeter depth immediately under drip ammeter. So this is a very important fund in our experiment. So then, and we set 5 treatments of soil moisture potential at 20 centimeter depth. This is immediately under the drip ammeters for potato were conducted in 2002 start. So that the 5 treatments, F1 is the same moisture potential is minus 15 kilopar. F2 is 25 kilopar. F3 is 35 kilopar. And F4 is 45 kilopar. And F5 is 55 kilopar. So irrigation was applied only when the soil matrix potential reaches the targeted values for F1, F2, F3, F4, and F5. So from this figure, it can be seen that the soil matrix potential in root zones is controlled very well, as we control the soil matrix potential at 20 centimeter depth immediately under drip emitter. This first one is for the treatment 1, treatment 2, treatment 3, treatment 4, and treatment 5. So we also found, the root is development is increases as the soil matrix potential is decreases. That means that when you have the good soil moisture condition and the root is smaller, and when the soil moisture is relatively, and there is drought conditions, and the root system is bigger, and this figure. And we found for potato, and the yield is increases as the soil matrix potential and decreases when it is reached to the 5 kilopascal. The yield is the highest, and then decrease, then turn to decreases, and for 55 kilopascal, the yield is the lowest. For radishes, the yield is also, the increases as the soil matrix potential decreases. When it is reached about the 40 kilopascal, so yield the highest. So evapotranspiration of potatoes is decreases as the soil matrix potential decreases. Then when it is the 50 kilopascal, the evapotranspiration is the highest. For radish has the same tendency. But the water use has very interesting curves. That is firstly, that is increases as the soil matrix potential decreases, and when it is reached to the about 25 kilopascal, and there is a larger the water use efficiency, then turn to the decreases, and then about from 45 kilopascal, and turn to and increases again. So the tendency of water use efficiency for radish have the same shapes you see as these figures, but the values are different. So after this and in the past 19 years, we have already carried out experiments for our 20 varieties or species of row crops, and the soil matrix thresholds were determined. The soil matrix potential thresholds for wax cone, oil sunflower, cotton, and tomato, bean, bitter melon, squash, asparagus, lettuce, radish, cabbage is minus 35 kilopascal. The soil matrix potential thresholds for potato and cucumber is minus 25 kilopascal. So the soil matrix potential thresholds for celery is minus 20 kilopascal. Then based on the above results, and we developed a simple but accurate method for microirrigation scheduling. So the irrigation quantity for each event is the same, and the irrigation time is determined by the temperature. For the purpose of farmers' use, you see, we printed different colors on the gauge, and then we just tell the farmers, and when the pins in which region of colors, and you may not need irrigation. If the pin is just out of the regions, you start irrigation. So this method, when we calculated as the first, we set 1 decimeter is installed at 20 centimeter depth immediately under drip meter. Second, irrigation amount for each irrigation event is the same, or we can divide it the whole crop growth period into 2 to 3 stages, and keeping the irrigation amount for each stage is the same. For most crops, the irrigation quantities for each irrigation event is 5 to 10 millimeter is enough. So then we observe the P of the tensimeter. Irrigation water is applied when the reading of the soil moisture potential is below the scheduled rates. So you see, no irrigation scheduling is very simple. The users just to read the gauge of the tensimeter. Then, if he found the pin out of the range of the colors that we tell them, they just push the button, start the irrigation. They don't need to mind whether water is enough. It is enough. Whether he can get hired, he can get hired. So, as for the perennial crops or trees, we suggest 1 decimeter is installed at 20 centimeter depth, immediately under drip meter. Another is installed adjacently at the 50 centimeter depth. Irrigation amount for irrigation event is also the same. So observing the pins of tensimeter at 20 centimeter the depth. Irrigation water is applied when the reading of the soil moisture potential is below the scheduled rates. Half days after the cessation of the irrigation. So they check the reading of the tensimeter at 50 centimeter depth. If the reading is still below the threshold of rates, it means irrigation quantity is not enough. And more water should be applied once again. And stop irrigation until the reading of it's within the rates. So now I'm going to introduce the irrigation scheduling for both the purpose of irrigation and fertilization. As we know, and the fertilization is very important to get the correct volume of the deep population, because salt is linked by the deep population.
Oh, yes. Professor Kang, I think you have muted your microphone. It's okay. It's okay now.
Okay.
Yeah.
Okay. As we know, and the soil moisture, as we know, soil water is a movement. Is as according to the soil water potential. But the soil moisture is determined the soil magic potential. So, as we told before, when we control the soil magic potential at 20 centimeter depth immediately at the drip emitter, we can maintain the soil magic potential in main root distribution layers. So, and then, we set the 5 treatments with the soil magic potential at 20 centimeter depth immediately at the drip emitter for cartoon were conducted in Kalamai City, and Wolf-Berry Orchard in Zhongning, this county, and from the 2008. So the 5 treatments were designed as the F1 is minus 10 kilopar, F2 minus 20 kilopar, F3 minus 30 kilopar, and F4 is the minus 40 kilopar, and F5 is minus 50 kilopar. So irrigation was applied only when the soil magic potential reached to the targeted value for each treatment. As indicated, that the salinity in the whole soil can be lengthened when soil magic potential at 20 centimeters and drip emitters was controlled higher than the minus 20 kilopar. So this red line means that before the season of the crops of the cotton, and so this line shows that the soil magic potential is threshold is minus 20 kilopar. From these figures, you can see the third length is very well. So we also found that when the soil magic potential is minus 20 kilopar, so yield of the cotton is the highest. So for the Wolf-Berry Orchard, the result is our experimental results indicated the same results. And that means when we control the soil magic potential higher than the minus 20 kilopar, third can be linked well. So this figure shows the electric conductivities of the distribution within 0 to 50 centimeter from laterals in horizontal direction at 3 layers. So for Wolf-Berry, the row spacing is 3 meters. So lateral spacing is also 3 meters. So the ICID distribution within the 70 to 150 centimeter from lateral in horizontal direction after 3 years shown by this figure. From both figures, we can see that third is linked very well. And the blue line is the beginning at spring, and the red line is the end of the season. So from both figures, you can see, and the third is reduced a lot. We also found, for the Wolf-Berry, and the yield is the highest when soil magic potential is minus 20 kilopar. The results indicated that the salinity in the whole soil can be lengthened, and the lengthened water requirement is very small. It's less than the 35 millimeter is enough. When soil magic potential at 20 centimeter depth and controlled as minus 20 kilopar. That means we use the very smaller amount of water, we can lynch the salt well. So for the about experiment results, we tested in potato field. The experiment study has been made in Wulan County, Qinghai Province. Irrigation was applied when the soil market potato at the depth of 20 centimeters is reached to the caliper. The 3 stations in our experiment are arid, located in arid area of China. So we found in Wulan County, Qinghai Province, 65 tons per hectare tuber yards of potato was obtained when the soil market potato at 20 centimeter depth immediately under drip meter was maintained above the minus 20 kPa at the drip irrigation, and no tendency towards the increased soil salinity was observed in the whole growth period. Potato yield and irrigation water use efficiency was 4 times of the local average potatoes. Yeah, this figure shows the salt conditions in the soils. You can see there is no salt accumulation. So according to the above experiment results, we developed the irrigation scheduling for both the purpose of irrigation and salt lynching. So it's we set the 1 decimeter at the 20 centimeter depth immediately under drip meter. The irrigation amount for each irrigation event is the same. The irrigation quantity for each event is about 7 to 10 millimeter. So we observe the reading of the tensimeter. Irrigation water is applied when the reading of the soil market potato to the minus 20 kPa. So now you can see this method is very simple, but very accurate. So finally, I'm going to introduce the several drip irrigation systems for different type of users. We analyzed the users in China, and there is many farmers. Their field field size is very smaller, but some farmers they can make groups together. And there is also the larger size of the farmland in China. So according to the farmers' characteristics, we developed the 3 models of micro-irrigation systems. First, we call the family by family irrigation model. Second, we call the group by group irrigation model. Third is the unified irrigation by specialized operators. First one is for the if in your micro-irrigation system there are many users with smaller size of land area. Second, it means that some users they can make several groups. And the third is for farmland. And for these irrigation models, we developed the products of micro-irrigation systems. This is a control head for groundwater, control head for the surface water, automatic and back flushing disk filtration system, automatic back flushing ground filtration system. Also, we developed the chemical injection system for
bandwidth link.
Professor Kang, are you able to hear us?
I think something wrong.
There is a bandwidth issue at his end.
Well, I think it is his last slide. In the meantime, Dr. Wawa, would you like to give your views and observations or share your experience from Africa? The first step.
Yes, good afternoon, everybody. Give my best greeting from China, and this is my great honor today to have Professor with us for the first webinar for the African Young Professional Forum. And I'm not sure about Professor Kang. Do you hear him now or not?
No, actually, we are seeing the slides. He's changing from to the last. Thank you, Professor Kang, for very informative and useful webinar on advanced micro-irrigation technology, which you have experimented in China for potato and other crops. And I'll request Dr. Wawa as a panelist to share his views and experiences from Africa. Dr. Wawa, please.
Yes, I think today this presentation is very interesting for all of us, especially for African countries. As you know, we are sharing the same condition, similar to what Professor Kang mentioned in arid and semi-arid, especially when you are going to use saline water and also for saline soil. And the most important here now, the main key, how we can control the soil moisture in the soil. And by this way, we are trying to keep the soil moisture within a range, not to reach to the wilting point and to be under the capacity to the limit, which not to reach to saturation. By this way, we can try to give the amount of irrigation water to a certain depth and to a certain time, which we are going to save more in irrigation water. At the same time, here, as Professor Kang mentioned later, but you didn't hear him about how we can use full automation of the system, how we can apply fertigation, how we can apply fertilizer to the required and to the accurate depths to the proper time, which can be used by the plant and for other crops. I think today this is very important for all of us, and how we can, by controlling the soil moisture, soil potential metric, we can control it to give the right amount to the crop at the most important time. And it is very simple as you hear. Professor Kang, do you hear me?
Yeah, I can hear you.
Yes. So I think this is a very important advanced technology, and how we can manage the soil moisture only by using simple tensiometer and to have irrigation scheduling. And this is very interesting, and you can see here after more than 15 to 20 years, they have applied this technology in more than 20 experimental fields, which we need to apply this technology in other and similar conditions. Yes, Dr. Parma?
Yeah.
Yes.
Professor Kang, we have one question at the moment, and we'll request participants to send their question by chat or as well as raise the hand. Once we see the hand is raised, then we'll give a speaking right to the person so that he can put his question or views or suggestion. So there is one question. I'll request Mr. Madhu to read it, and then Professor Kang and Dr. Wawa, they can respond to that question.
Yeah, this question is from Sampule. This is regarding promotion and more research in micro irrigation systems is key in climate change adaptation and mitigation. What programs is the Chinese Academy of Science undertaking to support developing countries?
Professor Kang, this question is also sent to you, and you can see from that, but we have read it for the benefit of all the participants that this question was raised by Mr. Sampule, and you can respond to his question.
Can you open that question button? If you click that button, you will see.
Oh, question button. Where is the question button?
Maybe you can allow me to have a reply for this.
Yeah, please.
Dr. Wahaba, can you repeat the question again? I didn't catch the meaning.
Baba, we can't hear you.
Dr. Wawa, I think you have muted yourself.
Yeah. Question button.
No, we are not able to hear you. Dr. Wawa, we are not able to hear you.
I can't hear you.
इनको अनम्यूट कर सकते हैं ऐसे Dr. Wawa, you can speak now.
Can you see the questions, Dr. Professor Kang? There is one right side. There is one.
I can't see the questions.
Yeah, if you click that button, you can see questions.
You can't see question. Or we can read it again. We can read it again.
Please read it again.
You hear me?
Yeah, I can hear you. Please.
Professor Kang,
Hey.
how Chinese Academy of Science is going to promote this technology in developing countries? This is the question.
I see. Let me try to answer. So, in current years, the Chinese Academy of Sciences is pay attention to support this technology to be used in developing countries. So, and maybe there is a project supported. As this year, we apply the research project in Egypt, and we want to build the experiment demonstration stations in Egypt, and then make the users can see the demonstration. And we also try to make the the training lectures over there. So we hope the users and the specialists in us. Maybe we start from next year. Okay.
Okay.
There is one more question, Dr. Waba. We have flashed the same.
You can read it.
This is from Mr. Mohammed. He says sub-irrigation is a method of irrigation where water is delivered to the plant root zone from below the soil surface and absorbed upwards. Sub-irrigation is used in growing field crops such as tomatoes, peppers, and sugar cane in areas with high water tables. Could you please clarify how we can make dual purpose technique, sub-irrigation and micro-irrigation?
Yeah, Dr. Wahaba, can you repeat the question?
As I understood, now the question about how we can apply sub-irrigation and micro-irrigation under the condition of high water table. Is that right?
Yeah.
Yeah.
A high water table, right?
Yes.
Yeah. It's it's okay, you know. And in our method, and we control the socio-economic potential. So if the water table is high, and it also can be used. This question, I catch the meaning.
Can I add something here, Dr. Verma?
Yes, you can add.
Even in such condition of high water table, it depends on to monitor the soil metric potential in the soil. So at a certain moment, we can apply irrigation water or we can stop. So it doesn't matter. At the same time, under condition of high water table, maybe you can need to apply subsurface drainage system to help in this situation also.
Okay, then there is another question which I'll read Mr. Madhu to read it, and then it has been also sent to both of you.
How long did these studies take? How long these studies take? What is the period of these studies?
How long, Professor Kang, how long is these studies carried out in the experimental field?
Oh, for my in my case, and we start our experiment 1999 until now. And for the January, for the users, maybe I think the 3 years is enough if according to the experiment design as in our experiment. 3 years I think is enough.
Yeah, there are more number of questions, and then there few persons have also raised their hand. So now what we'll do, we'll give a chance to some of the persons who have raised hand, and first we'll give it to
Let's put it with Amali.
Mr. Amali Abraham. We are giving it to him so that he can raise his question and views. Amali, can you hear us?
Yes, I can hear you. Thank you very much.
You can raise your question or suggestion, and now you can talk.
Okay, thank you very much. Thank you, Professor Kang, for the interesting webinar on micro-irrigation technologies. My question was more about the how to estimate the soil metric potential, which, according to your presentation, is one of the most important components for designing micro-irrigation systems. From the slides, I understand it's a time-consuming process, and I was thinking if you have, or through the period of study, you've developed advanced methods for determining the soil metric potential, like using available geospatial tools to reduce the time which is involved.
Okay, Dr. Wahaba, can you help me? Yeah, can you repeat the questions again? Yeah, I didn't catch the meaning detail. Sorry, my English is very well. So, and some questions, and I can't understand well. Please help me, Dr. Wahaba.
Amali, can you just be brief and just to the point what you wanted to raise?
My point is on available geospatial tools for estimating soil metric potential.
Yeah, actually, he's saying that what are the available tools, special tools for soil moisture potential measurement?
Yeah, it's we developed the tensimeter, and this tensimeter is very simple and in low price, so that can be used to observe the symmetric potential accurately.
Okay. Then we'll give speaking right to Mr. Mohammad Tukur Behro. You can now speak over microphone.
Hello, can everyone hear me?
Yeah.
Thank you very much, Professor, for this informative webinar. It is indeed very important, especially for developing countries. I want to drop this quick one. What do you think about the financial viability of this micro-irrigation technologies for developing countries? Because you understand the percentage of surface irrigation is like 80% in the world. And in developing countries, we have people that are really, really poor to afford these kind of micro irrigation systems. Are you also considering low cost micro irrigation technologies that can be affordable for developing countries? Because tomorrow, when you bring these systems, there is a question of affordability, and the world coverage of surface irrigation is still more. I mean, 80% surface irrigation is still being practiced. So now the technology should come to the developing countries, but in the affordability and acceptability in some cases is in question. So I don't know if you have something to say about this.
Can I apply for this, Dr. Varma? Hello? You hear me? Hello?
Hello, is my question
Can
understood?
Can you hear me?
I can hear, but I think the prof is not
Denise,
available.
do you hear me? Hello? Hello?
I can hear you. I can hear you. Are you talking?
Yes, I think first of all, thank you very much for your important point about the financial, and of course we have to consider all the conditions. We have to start with the low cost technology. Yes. Hello.
Hello, I can hear you. Please.
Yes, do you hear me? But Professor Kang is,
Yeah, the professor is not here.
so in general, now for the great challenge which we are facing in many areas, especially in arid and semi-arid and in developed countries, I think micro-irrigation in the near future will be a must, but at the same time we have to consider the cost. And of course, for developed countries, we have to consider how we can low cost technology. As Professor Kang mentioned, they have applied three models: one for farmer to farmer, group to group, and then for more sophisticated system. But for us, we have to consider the low-cost technology with micro-irrigation is a must for our conditions.
Thank you very much for your response. I really appreciate it.
Yes. Hello.
Yeah. Thank you very much for your response. I really appreciate it.
No, you're welcome. It's my pleasure.
Fertigation.
Dr. Verma, is there any other question?
No, I don't have a question. Whether there is another question?
Yes. Allow me to add the important point about this advanced technology. Yes. Dr. Verma.
Hello?
Yes.
There is any question? There is more questions?
Dr. Verma. Dr. Verma, please. This is a problem of technology. Hello, Dr. Verma. Hello. Hello. Dr. Verma. Hello.
ऐसी स्थिति है नहीं इधर चल नहीं रहा
Hello.